Hi, I'm Kevin Ward
And I'm Josh Mulligan.
with Tricky Fast Studios, and today we'll be further developing our Soldier AI. Ask for cover is actually a very simple state. So too is add back cover, but we'll get to that later. To understand ask for cover, it requires a little more discussion on how we should conceptualize cover and how our Soldier and possible other AIs should too. Adding cats. We'll get to this in a moment, but for now, let's see what cats we need to add to complete this state. Okay, so first add a add target to list action, and you're done. That's right, this is the only cat we need. And this is because the Soldier does not decide for itself which cover position it should take. Instead, it relies on the cover prefab we drag into the scene initially. All we need to do is change the list to named, input NPC paths as the value, and then turn on the path and reference name options, and input for the path cover, and then for the reference name, input the value waiting NPCs. As for the target value, specify owner. Before we go on to explaining the cover system in general, let's just quickly go over the state's sister state, add back cover. Add back cover. With every infinitely looping system, there needs to be a resetting of the original values. This is what add back cover does for the cover system. Due to the way in which the soldiers rely upon and request cover from the manage and cover prefab, two things need to happen. 1. Restore any used positions. 2. Change back to another state. The way we do this is quite simple. Adding cats. For this state, we only need 2 cats. Add target to list action and a change state action. In the add target to list action, we, like before, set the list target to named, input NPC paths, then, using the path and reference name options, input cover for the path and available cover positions for the reference name. For the target value, set the target to be owner, and then, using the reference name option, input current cover. This is going to be a game object value in the soldier itself, but we'll get to that later. Just know that this value will be a reference to the object that the manager of cover will provide for the soldier. Then, we just need to modify the target value and the state name. So the target to owner, and then for the state name, set it to initialize stats. Now that the state is set up, let's talk about cover and the system which manages it. Cover system. What is cover? In its most basic terms, it's just another position like the different waypoints we patrol to in patrol area. Their location, however, is based around where the soldier would take cover and return fire from an attacking opponent. Why do we need another object to decide who receives cover and who does not? The issue comes in when one or more soldiers want to take the same piece of cover at the same time. This occurs because, essentially, the soldiers want to move to the closest piece of cover available. So, if 1 is selected by Soldier A, then Soldier B should then select the next closest position. This means we need to create a manager of all cover pieces to decide this. We can find this cover manager inside of our hierarchy underneath NPC paths, cover. You will see that it's already pre-constructed and fully set up. But how does it work? So looking at our cover object, we can see a few things. 1, it has its own 2 states, initialize values and cover decision. Additionally, its value holder is chock full of different values, and there are many attached empty game objects. Third, it has a looping action. We can start by looking at the states. In the initialized value state, we perform two actions. One, we get the length of the list of cover positions. This is a local master list of cover positions and is not modified by soldiers during play. And then, second, add all of the cover positions into the secondary list from which soldiers draw from when they pick a covered position. You can also see here that we have ensure unique checked on so that we do not duplicate these values. We can then look at the cover position. But how do we trigger this transition? If we look at the prefab, we can see the looping action where we check for when anything tagged as enemy enters the ask for cover state. This will then cause the cover to transition to its cover decision state. If you remember from our coverage of ask for cover, the soldier will add themselves to waiting NPCs, a list on this object. But with all those waiting soldiers on the list, we need to go to cover decision to decide what to do with them. Looking at cover decision, you can see a couple of things happening here. First, we need to get the total number of NPCs that are waiting, and then we store the reference of that first NPC waiting in line as first waiting NPC, and then throw a 50% chance condition. Second, if this 50% coin flip succeeds, then the first waiting NPC gets the cover position, and all others waiting in line are told to transition to, stand, and fight. If the 50% coin flip fails, then the second NPC in the list is set to take cover, but the others in the list transition to stand and fight. Should the coin toss fail, and then there is only one NPC, it is assigned to take cover anyways. In all cases, we want to remove the NPCs from waiting NPCs. In essence, the cover prefab is choosing between the first two waiting NPCs in the list. All others are sent to secondary states. Take cover. So, let's move on to take cover. Here, we're going to first do a small conditional check on cover, because while cover decided what state to go to, it did not decide which cover position should be taken. This is where the soldier decides which one to take, and if there are none, which state to transition to in spite of that fact. So, the first thing we need to add is a new integer value into our soldier's value holder. Let's call this available cover total. This value will be used to check how many cover positions are left inside of the cover object's available cover positions. For the condition, we want to use an integer value condition and check if there is any cover left to grab. Remember, this state assumes cover has properly handled discerning who should get cover. To set this condition up, we need to set the target value to owner, and using the reference name option, target available cover total. Then, for the comparison type, select less than, and for the comparison value, input 1. Then, attach two action lists and set the second one to be an else action. Both will be serial typed action lists, but in the first one, we need to add only one action, a change state action. Then, set the target value to owner and the state name to stand and fight. This action will only occur in the event that there are no pieces of cover available in the cover prefab. In terms of what to add to the else action list, let's start by adding a ModifyBoolean value action, a get game object by distance in list action, a remove targets from game object list value action, a navigate action, and a change state action. ModifyBoolean value action will be used to denote that the soldier has been shot and that we shouldn't transition within our health trigger. So to set this up, we need to set the source value to target the owner, and then using the reference name option, input is shot. As for the negate field, simply leave it checked off, and for the target value, select owner, and for the reference name option, input is shot. Now this cat is set up. Moving on, we have a cat that is new to the lineup. This tutorial marks its unveiling and provides an opportunity for its use. We want to use this cat because it will help simplify our search for the closest cover piece inside of the Cover Prefab's cover positions list. This cat searches a list of game objects, finding the object which relative to the target satisfies the distance-based comparison between the two targets. You can find the object closest to your target, farthest to your target, etc. So, how do we set this up? First, we need to create a new game object value. On our soldier's value holder, we need to add this game object value. This value we can call current cover, as it is the cover we want the soldier to move towards during play. After this, we can begin filling in values. For the target list, let's set the values to be named and input NPC paths. Then, let's use the path and reference name options. For the path, input cover. For the reference name, input available cover positions. This will target the hot list on the cover prefab, from which we can draw from to select a piece of cover. For the store-in value, let's select owner, and then use the reference name option and input current cover. Now, we want to select the type of distance comparison between the target list and our target value. Let's select less than, and as for our target, let us target the owner. Now, we are looking for the closest available cover piece from our available cover positions and storing that reference in a localized variable. The next thing we want to do is remove that found cover position from the cover prefab's available cover positions list, so that when cover decides another soldier wants to take cover, it does not give the same cover piece away. So, inside of our remove targets from game object list value action, let's set the target value to owner, and using the reference name option, target current cover. Then, for the list value, let's set the target type to named, input NPC paths, and then, using the path reference name options, input cover for the path, and then available cover positions for the reference name. This way, we can pull out our localized value from the list of available cover positions. One of our last actions here in this state is also the most important. We need to actually move to our localized cover position. We can do this in our navigate action by setting the target value to owner, setting the destination to owner, and then using the reference option to input current cover, and then using owner again as the animation target with a path option set to enemy model, and providing for the walk parameter name moving. All this will help guide our soldier to the current cover game object provided from the cover prefab, and will set them to play the walking animation as they move towards their destination. Finally, we can now change states to our attacking state because we have reached the cover position. To do this, in our change state action, all we need to do is specify for the state name attack from cover while we set the target value to owner. Attack from cover. Okay, so let's move on to attack from cover. This state's purpose is to attack the player from a position of cover. While it attacks a player, it should shoot in a spread and also account for when the player is too far away to logically make sense to keep engaging the player, and then to transition when that happens. Let's start by adding our main cats. Add a face target action. Next, add a action list. Finally, a proximity trigger. The latter half of these we'll expand upon more considerably, but for the former, it'll be relatively straightforward. Let's start on our face target action. So, the first thing we need to do is make sure our target value is set to owner. Then, for the face target, let's set it to player. This will turn our soldier towards the player, and now it's time to make sure this happens continuously so that the soldier will face the player as it shoots. To do this, set the movement type to continuous, and then set the speed, let's say about 500. Finally, let's only rotate on the Y and Z axes and not the X axis, leaving it checked off. We now need to move on to our action list and add the logic that will allow us to damage the player. To start, we need to add a wait for frames action and a looping action. Inside of this looping action, let's add setBoolAnimation param action and another looping action. Then, inside of this looping action, let's add a setVector3 value action, a setRandomVector3 action, a playSound action, a translate action, another action list, a raycast condition, and finally, a move action. Hopefully your head isn't looping around infinitely. Let's just cut this down to size though. So, let's go back up into wait for frames action. We need to set the frames to wait value to 30. This will give enough time to coagulate the different bits of info needed to run the rest of this action list. Now, let's go into the sibling looping action. You need to make sure that the run type is serial, the minimum random is set to 0, the maximum random is set to 0, the delay is set to 5, the loops is set to 0, and check at the beginning is checked off. Why is it set up this way? Well, the looping action is set up in this manner so that we can control the enemy shot pattern. We want the enemy to wait 5 seconds before each burst of fire. If we didn't, it would be a nightmare to try to evade his attacks. Additionally, we don't want him to attack only a few times. In this state, we want our soldier to attack forever. At least, this is until the player is out of range. So this is why the loops are set to 0. Now, inside of this looping action is where we want to shift our attention so that we can define what this while loop does. Look at the setBoolAnimation param action. This will set up the soldier with our preset animation values. We need to set the target to owner, and using the path option, we need to specify enemy model. Then, for the parameter, let's provide aiming as our desired term. Finally, let's check on value. This way, we can set our soldier to properly aim at the player during shooting. Next, let's move on to the next looping action. This looping action controls for each individual shot in the burst. So, the delay determines the rate of fire for the soldier's shooting, and the number of loops determines the number of shots fired. So let's set the run type to serial, and set the min and max random to 0, and the delay to 0.2, and the loops to 5. We can leave check at beginning off. Okay, we can now look at the individual actions within this loop. To set up the setVector3 value action, we need to create a new vector3 value called shot end position. This value will be used to reset the spread of the shot each time we re-enter this loop. So, now that we have this value created, let's go back to the setVector3 value action. For the target value, let's select owner, and using the reference name, let's specify shot end position, so that shot end position will be re-zeroed upon each loop. As a side note, the way in which shooting works for the soldier is by using a trio of empty game objects we can see attached on the soldier as children: shot spawn, shot end, and shot end origin. These all work in tandem to create the illusion of a recoil pattern for the enemy. Anyway, the next thing we need to do is modify shot end position with a randomized offset to create the spread pattern for the individual shot we are taking during an individual iteration of the loop. We can do this in our set random vector3 action by setting the target value to owner and then providing for the reference name shot end position. As for the min value, let's put -1 for the x and -1 for the y, and then 0 for the z. Next, for the max value, let's put 1 for the x and 1 for the y, and again 0 for the z. This way our spread will move in a randomized amount up, down, left, or right, but not forward or backward. Having calculated the spread, let's play a sound signaling the shot being fired. Instead of our play sound action, let's target the soldier through using owner, and then for the clip, let's navigate over to the project window, and in the audio folder, let's find gunshot 2, which is the sound effect we want to play when the soldier fires his weapon. Let's input this as the clip inside of our play sound action. We then set the volume to 0.7 and leave everything else as is without change. Now, let's visually show that the enemy is firing. To this, we can add one more cat to our looping action. This cat will be a spawn action. This cat will also need a new value. Let's go up to our soldier's value holder and add a GameObject value component. This will act as our spawn point for the particle effect created for our shooting loop. However, because this object's transform will be relevant to our spawn action, we need to also modify its transform and be careful not to change its values. Let's name this value muzzle flash particle. What would be a good coordinate set for this object relative to the position of the gun when the soldier aims his weapon? We could go to our enemy model and turning on our aiming bool and see where the muzzle of the soldier's gun lines up. Fortunately, I've already written down what XYZ we need for this instance. Let's put 0.046 on the X, 1.502 on the Y, and 1.025 on the Z. This feels good to me. This feels right. Now, that this target is set up properly, let's go to our spawn action, and for the target value, let's select owner, and then, using the path option, let's specify muzzle flash particle as the value. Then, for the parent, let's change it to named and input level as the value. And using the path option, input spawn holder as the value. For our prefab, we want to use the prefab muzzle flash. We can find this prefab inside of prefabs particles. We then want to lastly ensure that set transforms is checked on and that spawn on clients is also checked on. Now we can actually move shot end and set up where we want to shoot based on our previous calculation. Let's go into our translate action and set the target value to owner, and then using the path option, input shot end. Then for the amount, let's change the selection to owner, and using the reference name option, let's input shot end position. We want to also be sure that the duration is set to 0, the movement type is set to duration, and the XYZ options are checked on with the clamp to ground and clamp distance unmodified. This way, the shot end will move from its position to the offset using shot end position. Now we can get to the next item, the action list. This action list might seem oddly placed, but is actually very important to help indicate visually the trajectory of the shots from the soldier. This action list will help us set up for the soldier's tracers. Now, thankfully, this process is already set up for us for the most part. If you notice in your scene's hierarchy, you can see a prefab named Object Pool Generator. This object is a state machine of its own and handles objects which will need to be spawned at a high rate, but would be too taxing to follow the instantiate and destroy paradigm. Instead, we can use object pooling to accomplish our goal. You can learn more about this specifically in a tutorial covering the topic or from Unity's own manual entries on object pooling. All we need to know for the moment is that on our object pool generator, we are creating varying object pools for different purposes, and here we are utilizing the pools to use those objects as if we were spawning them. To do this, let's go back to our action list and add a few different cats. First, let's add an acquire object from pool action. Then, let's add a move action, a rotate action, an emit particles action, another move action, and a change state action. First, let's go to the acquire object from pool action and set the pool name to be enemy tracers pool. Then, for the parent, let's set the target to owner, and using the path option, set the target to tracer. This object is an empty object in the soldier, which helps house where to put our tracer shot initially. As for the other values, let's keep the binding target to owner, and then for the count value, let's input 1. Next, let's move on to the move action. Here, we need to use specific language when describing what kind of actions we want to take in terms of the tracers. So, first, let's set the target to owner and use the path option over the reference name. Using the path option is a more direct way of referencing information. Here, we want to reference exactly the tracer objects pooled onto our tracer empty game object that is childed to our soldier. So, let's set the target to owner, and then for the path, write tracer obj pool enemy parenthesis clone close parenthesis. For the destination, we want to set the target to owner, and then set the path to muzzle flash particle. This way, we can set the tracer to its proper start point and then manipulate it further before firing it. We need this move action to perform its action instantaneously. Otherwise, we'll have strange positions and rotations for our tracers when shot. So, set the duration to 0 and get the movement type to duration. Make sure to keep the XYZ options all checked on. And now, we can go on to the rotate action. Inside of our rotate action, we need to set the target value to owner, and then use the path option to input tracer / tracer obj pool enemy open parenthesis clone close parenthesis. Then, for the orientation, we want to select owner, and then for the reference name option, we want to input open caret transform close caret dot local Euler angles. This will reference the Euler angles directly on the soldier itself. This is how we want to orient our tracer before we release it into the wild. Finally, we want to set the duration to 0 and make sure to leave the movement type as duration. Next, we can now visually show our tracer having been put into its correct position. Note that the particle system that is our tracer is set up such that the logic we write here is what plays the particle system, except in a more limited sense. Here, we want to use emit to flash the tracer visually before launching it. So now, let's put for the target, owner, and then, using the path option, let's input tracer / tracer obj pool enemy open parenthesis cool close parenthesis. And then, for the count,
Let's put 1. The next thing we want to do is set the tracer endpoint. This will tell where the tracer should move towards. This may be a little confusing, but the idea here is the tracer will propel itself rather than us in this moment here in the soldier shooting loop. To do this, let's go over to our other move action and set the target to owner. Then, using the path selection, let's input tracer obj pool enemy open parenthesis clone close parenthesis / endpoint. This will target the internal endpoint value inside of the tracer obj pool enemy clone object and tell it where to fly when we release it. Now, to tell it where to fly, let's set the destination to owner, and then, using the path option again, let's input shot end. We can set the duration to 0, keep duration selected as the value for the movement type, and finally, we can still keep the XYZ values checked on and do not need to worry about anything else. Finally, we have the change state action, and now we have all the values calculated in the mere milliseconds it took for the computer to process this information. We can now loose the tracer. To do this, all we need to do is specify as a target owner, and then using the path option again, we can input tracer obj pool enemy clone to reference the state machine on the tracer, and then for the state name, provide wait for impact. Now the tracer will head towards its understood destination. With this out of the way, we can move on to actually changing the health of the player in the case that they are hit. So, let's go back to the raycast condition we put in earlier. This needs a little setup, but is easy to do. So, let's go to source, when we shoot our ray, and select owner as our source target. Using the path option, let's input shot spawn. This is the empty gaming object already on our soldier. So, let's go to the collide target and select player, and for the destination, let's select owner. And then, using the path option, let's input shot end for the destination. If you note at the very bottom of the raycast condition, you'll see there's hit points 2D and 3D, which return the 2D or 3D position of the raycast in the case of a true case evaluation. These aren't relevant here, but they are on the various tracers we use. Feel free to investigate at your own leisure, but if they give you trouble, then simply switch the type to value, effectively making it inconsequential. If we navigate down our hierarchy, we can see shot end is 40 meters away and is the max range of our shots. This way, we always know where we shoot. You can adjust this value to suit your own purposes. For now, let's perform actions depending on the case evaluation. We want to add 2 action lists and mark the second one as an else action. Inside of the true action list, we want to add a modify integer value action, a move action, and a play sound action. For the else action list, we need to add a move action. So, let's modify these values and then move on to our detection triggered action. The modified value action inside of the true action list needs to have its source value set to targeted, and then, using the reference name option, needs to have the value player health inputted. This is an integer value on the player itself, and it's not covered here, but we covered it before in the player section of this tutorial. Now, go to the operation and select subtract. Then go to the modification amount and input 20. This is the amount of damage we'll be dealing to the player. After this, change the target value to targeted and input the reference name to player health. This completes our modify integer value action. In the following move action, we need to set the targeted value to owner, and then use the path option, specify shot end. Then we can again target owner for the destination and input shot end origin for the path option. We can leave the duration at 0 and have the movement type remain duration. As for the play sound action, we want to indicate that the player has been hit. So let's set the target to owner and find hit hurt 1 inside of our project window, inputting it as the value for the sound file of the clip. Finally, we can set the volume to 0.7 and leave everything as is. All we need to do for the else action list is simply specify the same values for its move action that we did for the true action list. Then, we can do the same for the very last move action at the end of the parent looping action. Excellent! Now we've covered all possible cases for when we need to reset our shot end. On to our triggered action. This triggered action is fairly simple to set up, and as previously mentioned, is the way in which we check for when the player is out of the soldier's detection radius. So let's add our first cats. We will need a bool value condition, and then inside of this we will need an action list. Here we'll then need to add as children of this action list a play sound action and a change state action. Finally, back to the bool value condition. Let's add a destroy object action. For this destroy action, let's mark it as an else action. With that out of the way, we can set this up. Go back to the proximity trigger itself. Here we want to set the negate option to true, specify owner for the target, set the radius to 25, the collider target to player, and keep everything else the same. This way, once the player is 25 meters away from the soldier will, in essence, lose contact. So, to represent this, let's modify our remaining cats. Inside of the action list, which we can leave as serial, we can set the negate option on the bool value condition to true, and then set the target value to owner, and the reference name to is dead. In the case that the player is in fact not dead, we want to indicate a loss of detection and add back cover to the cover prefab on NPC paths. To do this, we can set the target to owner on our play sound action, and then input the loss detection sound effect from our project window. Lastly, we want to check on keep playing after stop and set the volume to 0.8. Now we can move on to the change state action, and here all we need to do is set the target value to owner and then select add back cover as the state transition. Finally, to wrap up this whole section, we just need to go to the destroy object action and make sure it's an else action and set the target to owner. That way, in case the soldier is dead, we can destroy him should this logic ever be reached. This concludes attack from cover. This concludes this part of the tutorial. I'm Kevin Ward.
And I'm Josh Mulligan.
And see you next time.